Just lost the recording for the last problem. The voltage across a device and the current through it are shown graphically here. Sketch the corresponding power delivered to the device and calculate the energy absorbed by it. Okay, so hopefully by doing this we'll also just review a few things about power and energy as well. So power equals IV. That's always the way I think about it. You can also use Ohm's law, V equals IR, to substitute in for I and V and get power in terms of current and resistance, or voltage and resistance, but P equals IV is the way I always think of it. But you also need to remember that power is the derivative of energy. And if you had constant power, then your energy would be power times time. And sometimes you have that. So if you end up with a problem where you have a power and you end up with your power is 5 kilowatts, and the question asks, it's been running for 3 hours, what's the amount of energy? You take the power times the time. In this instance, we're not going to have a constant power, so energy is going to be the integral of the power with respect to time. Okay, but first we need to sketch the corresponding power. So we have our time, 1 second and 2 seconds. And the power is the current times the voltage. And this is the voltage is the line, the diagonal line, and the current is the straight line. So the current is a constant. So if I multiply a line by a constant, I just get a steeper line. And in order to figure out the graph of a line, I only need to know where 2 points are. So if I look at this bottom point, so right here, so at t equals 0, V equals 0 and I equals 10, so power equals 0. So this is going to be power, and our units, this is amps, this is volts, so our unit will be watts. At t equals 1, our voltage is 5 volts, and our current is 10 amps. So our power is 50 watts. Oh, I should have made negative side on this. Okay, so the line times a constant is just a steeper line, so I know that's still just going to be a line. Now, the same is going to be true on this other side. I just need to get 2 points because it's still just going to be a line. So at the other side of t equals 1, at t equals 1 plus, this was t equals 1 minus, at t equals 1 plus, V equals 5 volts, and I equals 5 amps, and so our power equals 25 watts. And at t equals 2, our voltage is 0, and our current is 5, so our power is 0. Oh, I guess I didn't need a negative side. Okay, so that is a graph of our power, but the question also asks me for the energy. And so the energy is the integral of the power with respect to time. So I could, and the book always does, come up with equations for these and integrate them. But I don't see any reason to do that because I can draw triangles and find areas. And that's a lot easier for me than... The equation of this first line is easy. That's 50t. Because it's just rise over run is 50t. The second one, I'd have to figure out what the y-intercept is and all of that. But, so this is just the area under the curve. So the first triangle is 1/2 times 1 times 50. So it's 1/2 base times height, plus the second triangle is 1/2, and the base is 1, and the height is 25. So that's 25 plus 12.5, which is 37.5 joules. So your energy will be in joules.